Okay, let's look at an introduction to Splunk and how we analyze data with inside cybersecurity. Okay, so we'll have a quick look at why we might use Splunk and also then on to some of the applications. So why? Obviously to protect customer and citizen data, but if an organization does any financial transactions, then they must comply with PCI. And we can see here that a core part of this is to monitor and test networks and also to implement a security policy and maintain a vulnerability management program. So as part of this, we might use Splunk to be able to monitor the transactions on our network. So if we define before an incident, during an incident and after, we might be collecting data here that might be useful within the incident, and then from a forensics point of view, we might be able to look at the data that we've gathered after it. So we need to make sure all the time that we're collecting the data, just in case we need it for the real-time response or after it for the forensics analysis. And what we basically have to do is to build up a timeline of activity, to be able to paste together what actually happened when, and hopefully be able to understand what the basic time thread was. And we have logs from across the whole infrastructure. That's from data at rest, such as from files that are changing, such as the create, read, update and delete, thumbprints of the files and so on. And then we might look at data in motion. That's from our network scanners, IDS systems and firewalls. And for that, we look at network packet logs, web logs and so on. And then there's obviously data in process, and that's the data that's running, such as the processes, the threads and memory. And we might look at some of these logs to be able to understand the data in process. In terms of what we might want to log, then there are many different things on the network. We might be monitoring emails, print monitoring, changes to registries, TCP logs, environmental, Active Directory logs, where people log in and out, file system changes and so on. And overall, the more data that we collect, the better the timeline that we'll be able to build up. But obviously, the more expensive it is to be able to collect and process and analyze this data. And the complexity is that we can typically have hybrid networks where you might have some cloud infrastructures, different types of web technologies, different databases, application servers, and so on. And we must bring together all of this within inside our big data infrastructure. Okay, so let's have a look at Splunk and how it actually works. So we'll just open up our example here. This is Buttercup Games, and we can see here there are over 100,000 events in there, and these are the logs that we have. Okay, we have 8 sources. And access.log is the web log. This is a time span on the system. We'll just have a look to see what that looks like. Okay, so the SPL here gives us our basic search that we're performing, and we'll need to go to all time. Okay, so it gives us a time window. From there we can see it's 7 hours, 7 days and 1 hour from there. But obviously what we can do is we can reduce down that time, and we can zoom in. We can click on a time, double click, and then we'll go to that day, and we can obviously zoom back out and have a look in more detail. You can keep zooming out there. And then we can pick up and analyze just for certain time windows that we want. That's for 12 days. And we can move that along like that, and we can analyze such as this. But we'll go back to our preset all time. We'll just have a look. Okay, so in our web log, we see the IP address of the client, the timestamp, the URL, the referrer, the response code, and the TCP port of the client. We also get a string which will identify the web client that's been used. Okay, and then from this we can actually do some really in-depth analysis from a security point of view, and also for the analysis of our website. What Splunk does is it be able to parse each of these fields automatically and build up some interesting fields which we can actually analyze. So client IP is one here, where we can see these are the top referrers, the top IP addresses that are coming into the website. We can also look at rare ones. As we do this, our commands change here. So it's easy for us to copy and paste the command from there, and we can also copy and paste from the URL string to be able to repeat the analysis again. Okay, so this is our basis here for that, and what we'll do is we'll have a quick look to see how this website is set up. Okay, so this is a website that sells games. So there's a category ID, and that's the category of the game, and then there's a product ID that goes along with that. So the user can actually select one of a product and then add it to the cart. They can purchase it, remove it from the cart, and so on. And for this, when we do a scan of the top level, these are the top level names that we get, and I'll show you that in a little minute. Okay, so these are the links that we have with a GET. With a GET, that's equivalent to just posting a URL into a web browser. Whenever there is a click on a page, such as when someone adds something to the cart, there is then a post, and the post in this case has an action, and then that's picked up with a category ID and product ID here. Okay, so those are the main the main elements of this website, and I'll just show you how this works. Okay, so we'll go for get, and what we normally do is we normally pull down this one of the packets here, and we can actually have a look at all the elements here. So as I said, then if we wanted to look at the files that were accessed at the top level, then obviously we will look for it's just here. Okay, so these are all the files at the top level whenever there was a get. So the top one is product.screen, category.screen, old link, cart, and so on, and then there are files here. So these are the only top level gets that happen on the system. Okay, so the majority are these four there, and this one here I think is to show the cart. Okay, so that shows us that. So what we can do is that we can also, for the gets, we can actually look at the IP addresses that are accessing from the get. And we see the top address is this one here. We can click on that and it will build up our search string for us, and we can see that this is the top IP address for accesses for get, and that's the accesses there. We could go to a single event day, and that gives us that in there. Okay, so this, it doesn't change the time here. When we double click, it doesn't change the search string, but it changes the timeline. So we'll go back to our preset all time, and we'll have a look there. Okay, so these are all the accesses from that IP address and the times and so on, and we can drill down to find out what is the main category that it's a category ID. So 64 times it was strategy in there, and then 42 times from the IP address it was arcade. Again, we can click and that will build up our string there for our searches, and you can see here it gives us our timeline for that. Okay, so it's a powerful tool to be able to drill down and identify things. And one thing that we often look for is for the status code. So the status code is what the HTTP reply gives us. So 200 is a successful reply. So often we look for the ones that were not quite as successful, such as 404, 500, 503, and so on. So on that one, we're looking for status. And there we are. The top one is 200. That's okay, 84% time, but we get some other codes here. So the one that's interesting is probably the 404, which means file not found. So either someone is fishing for something that isn't there, or we've forgotten to put the file on the website. So we'll have a look at 404. Okay, so that's status 404, and we can actually find out what address had the highest number of 404s, and again it was this address here. But we could drill down and look at, say, this address and find out all the 404s that were generated from here. Okay, that's for the status. So if we go back up to the get, and we have a look to see at what the gets were. So we're looking for the file. And the strange thing we see here is this file, and also signals, and another one there which aren't very popular in terms of the accesses. If we go to status 404 again, we should be able to see that this file here is accessed, and we're getting a 404, and it's continually accessed too. So we can do a free search for that one. And there we are there. Okay, so it was accessed 58 times over this time period here, 2 accesses there. And if we want to find the IP addresses which were trying to access that file, again we go to client IP, and we can see this address here is accessed at 3 times. This is one that we've not actually seen before, so we'll have a little look to see what that is there. And we can see there were 2 accesses there from this address. Okay, so often what we're looking for is an anomaly or a difference from the normal accesses. You can see there's Opera twice, and then this one we have Firefox there. Okay, so the next thing we can look at is the action. So if we look at our gets, and with the gets we've got some actions here. So what we'll have a look at is the purchase. So whenever someone purchases, so we've got 188 purchases. So we could actually have a look to see what were the categories of games that were purchased. So these are all the purchases. That was the most popular day, 22nd of April, 40 purchases. So it's not, they're not definite purchases because we might get a status code that isn't successful. Okay, so what we want to do is to look at we want to now look at post. Okay, so these are all the actions with purchase here, and whenever we've clicked on the cart to make a purchase, and here is the item ID here, and there is the category ID and the product ID from there. So let's have a look at this one. Okay, so there's a category ID, and we can see here that the in this case we can see 885 accesses for purchase for strategy. Now what we'll do is that we'll just go for so that was for status equal to, if we go for now for status equal to 200. So these were successful purchases. Okay, so we have category ID. There we go. Okay, so there's 806 strategy, 493. So these are for purchase with a 200 code. But now we might want to look at the purchases that didn't complete successfully. So this will be purchases where it's not equal to 200. Okay, so we've got 325 events here, and we can see there's a 503. I think that's a server error, and there's another 503 here. But we can actually determine what the status codes were when the user tried to purchase it and it wasn't successful. So we just find status. Okay, and mainly it's a 503 error that we're getting there. I think that's normally a server type error that's happened on the purchasing. Okay, so this is whenever the user has an action of purchasing something and the status code returned from the post is not 200. Okay, and then we can find out what the category ID was when it was not successful. Okay, this is there. So there was 79 not successful strategy, category IDs for purchase. Okay, then if we want, we can now rank that in terms of the category. So we'll just go back to that one again, and we find our category ID. Okay, we'll just click on there. That will give us that. Okay, so this is there's a post action is purchased and not 200, and then we can then limit to the top 20 and with the category ID, and then we can basically visualize that, so it gives us a table and also our chart if we need it. Okay, so there's the statistics and the visualization that we have. So you can see there that the search doesn't change, but what we're doing is looking at the core data that it's generating. And then there's a field called user agent. So we'll go back to get again, and what we want to do is to find the top browsers that are accessing the site. Okay, and that's within inside user agent. There are 26 different user agent strings. So we can see the top one here is Mozilla. Then we have goes down there, and for this one, this is Windows, and this is a Mac here. Okay, so we can go to our top values again, and we'll take the top 20. So here it is as a chart. We can see all the different browsers that are coming in, and this is useful from a marketing point of view. We can start to understand what is the most popular browser that is coming in, and it should give us an idea about the machine type that's also coming in too. Great thing about Splunk is that you can copy the URL here, and we'll get the same chart again, hopefully. If we open up another window, we can copy it like that, or we can copy it like that too, and then it'll give us the same string. And then once you have your string, you can then modify it as you need to. And we can maybe just go for the top 5 and then, and there they are. Okay, so it's a useful method. So what we can also do is to be able to chart, and in this case we're looking at the user agent again. Okay, so we just have we can have an evaluation here, and that will search for the word Safari in here with inside our data sources, with inside the web. This is bringing all the web logs together. It does an evaluation and then a count of Safari. It's going to name it as Safari, and then a count of Chrome, and then a count of Mozilla, and then we'll be able to chart that. Okay, so there we go. So in this case, Mozilla is the highest, followed by Safari there. Okay, so we can look at our stats. There we go, 37,000, over 37,000 for Mozilla, 14,000, over 14,000 for Safari, and only 9,051 for Chrome. Okay, so that gives us that data. Okay, so let's have a look at this search. Okay, so we can quickly go to wherever there's been a post, purchase, and we can list for the product ID. Okay, so then in terms of the product ID, we'll have a look here. There we go. So this is the products that have been purchased, and we can see the top product is this one here with 275 different purchase actions on it. If we wanted to see when it was being sold, then we could go here and we can see there wasn't many sold there, but then it increased there and maybe reduced a little bit at the end there. Okay, so this has been a basic introduction to Splunk. As I said, that was the structure that we found very easily from the log. Then we looked at the get and how we could use the analysis of the log elements to search for things, and especially to look in terms of the client IP that we could get from here, or we can actually get from our search. Then we have especially looked for different status codes to be able to see where there's errors and problems, and then we could drill down to looking for status codes and for specific IP addresses, say, and then we did a search for files that were suspicious. Then we could look in terms of the different actions, different ID fields for our site, and from there we could actually start to look at things like the category ID, which is set in the URLs. Okay, so you can see the power that we have with inside Splunk. Once it's mined, then we can really create very complex searches. Okay, so that was a basic introduction to Splunk.